That's what it was.
You think so?
Yeah, I just fixed it.
It's been like 4 days.
Yeah.
That'll teach you.
I think they hooked that AI that plays Go to figure out if they're logged in or not. Okay, so this is I'll put this under the Raspberry Pi category.
Yeah, it's a Pi.
It's Raspberry Pi stuff.
It counts.
Yeah, okay. And welcome to Desk of Lady Ada.
Hello again. Welcome to another Desk of Lady Ada. It's a nice and dark Saturday night. We've had a lovely day. And now it's time to get to some Raspberry Pi Python hacking. And that's what we do here Saturday night at Shay Ada. It's me, Lady Ada. This is my desk. And with me is Mr. Lady Ada, who's on camera control, quad cam. Hello. And he's also the band. So I've been actually working pretty hard over the last week to redo a whole bunch of our in-house testers to use a standalone Raspberry Pi. Part of our Get the Feather Out campaign, we're trying to make sure that we have lots of feathers made and in stock. And one of the things that really helps with that is, I can't make the pick and places much faster, and I can't make it faster to put them in a bag and put a barcode on them, but I can make it faster and easier to test them. And the faster and easier it is to test, the more you can get in stock. And so this is part of that deal. Also, historically, I've had all these feathers tested with a computer with an ST-Link, and it works pretty well. But then the Macs upgrade from Yosemite to El Capitan, and then USB change, and the ST-Links don't work as well. And then I've talked about that in previous shows where I've been using OpenOCD on a Raspberry Pi to program an ATSAMD Cortex-M0 really, really fast. And using BitBang GPIO is great. But today I'm actually going to be going back and updating the tester for an older product. This is for the ATWINC1500 breakout. So this is a really nice little Wi-Fi module from Atmel, which we found out a couple days ago does TLS 1.2. They didn't update the docs, but if you want SSL TLS 1.2, this does it.
Show this under the overhead. Here's a zoomy view. You can just look at this thing.
This is the module. And there's a G on it because this is the gold. So it's important whenever you design a tester that you have one board that is good.
Gold is best.
That's your golden sample, because this way if the tester doesn't pass on this and there's something wrong with your tester design. So it's always good to have a gold sample. So this also has a marking on it telling me that it has the 1944 firmware on it, which is relevant for deep, complex reasons about firmware updates and Atmel and how you update certificates and stuff. So this is the gold. It has a G on it, so we don't accidentally put it in the store. This is the one that we use. This is what comes out of a pick and place. And this is a Raspberry Pi with a Pi TFT, and I had some text on it, but don't worry about that. Can you zoom out to show the tester? Because I don't want to lift it. And this is the clampy tester that we've got. You can see it says PID 2999 on it. And this has a toggle clamp and a pogo pin bed. And underneath is an Arduino Zero. And we use an Arduino Zero for a bunch of reasons, but the most important reason is during the test procedure, I update the SSL certificate stored in the module. And to do that, I use a firmware updater sketch that really only works on the Arduino Zero. So I use an Arduino Zero underneath here. You can see it tucked underneath. It has the debug port and power port taped up with Kapton tape so that people who run this tester don't accidentally, because there's 2 USB ports, they don't accidentally plug into these. You should only be plugged into the native port. But this is just the physical clamp. So it just holds it down in place and connects it to the Pi Zero. So this is actually right now connected to my computer, and I'll show you how I used to do the test for this.
Now, I'm going to let you finish, Lady Ada, but I thought I would take a little bit of a break this second and do a little detour with some maker business tips.
Okay.
So one of the maker business tips that I think we should mention is, as you went through this whole thing, there's a few things that you did. And I think unless people hear it, they might not think about it. So we have PIDs, and the PID is on the tester. So that way, it's very clear what is on the bag.
Product ID 2999.
And then it's etched on the tester. It's very difficult to take this number off.
Yeah, it's permanently etched. And also, we don't use the name of the product.
That's right.
Because it's very easy for people who don't know electronics. We hire people and they're not electrical engineers. And the people who are not electrical engineers will probably be working for your company at some point. Telling them like, no, that's an Atmega 328, not an Atmega 324.
It's an AVR, it's an Atmel, it's an ATWINC. It's a Broadcom, it's a Wicked.
It's confusing.
So Wink and Wicked, it's easily a couple letters off.
So they grab it and it might be the same shape. So going by PID, also we have some products that are really deceptively similar looking. We have the BME 280 and the BMP 280. 2 different breakouts, 2 different sensors, and they look identical. You cannot tell the difference until you actually run the tester.
And the other thing is, can you take the board off the tester and flip it over? So, one of the things that we invested in, and I don't know if there's a better one or not, but basically, like, get a label maker. Like, everything around in this entire place has a label.
Well, we have we had a video where we repaired our label maker.
So I think we get the ones from like Brother. I don't even know if they make other ones.
They're actually pretty good.
They've been making the same thing for like 30 years.
If you don't have a label maker, use a silver Sharpie. Silver Sharpies are great because they show up on PCBs really well.
So anyways, like a lot of the things, if you just look at like, this is survivor bias. Like all the stuff that you see we do is because like we probably figured out all the other ways to do it that don't work out. Like this works out really well.
What's funny is like I don't even think about it. I'm like, like of course.
So anyways, I want to take a detour. Let's get back to the action.
Okay. So we have this board basically attached to an Arduino Zero, and then if you go to the computer, this is the sketch that I have uploaded to the Zero. So do you want to maybe we'll zoom into a window? I can always keep the window this
No, I can. I'm going to have the full-size one, and then I'm going to zoom in on the window that you want. So what do you want, this window?
Yeah, I think that's good. Like that, just because it's a little bit long. The text is a little small.
Is that all right?
Yeah.
Okay.
So this sketch, and I uploaded it to the Arduino Zero. It basically creates, the Wi-Fi object, and when you open up when you open your serial console, because it waits until the serial console is open, it says, hey, I'm the tester for the Wing1500. It says, okay, I'm going to do the Wi-Fi scan. It checks to see if it found the modules. This basically tests all the SPI pins and the enable pin, and basically all the data communication pins, because if it doesn't work, it would not find the breakout. It makes sure that the firmware version installed is correct. We used to get modules with, the firmware version has changed over time. Now it's 19.4.4. So make sure that the firmware is the correct version. Then it prints out the MAC address for the module. That's burned into the module. It's also, I think it's printed on the top. Yeah, it's printed on the top and burned into the module. And then what it does is it scans for all the networks, and it actually runs this program called list networks. That's this function. Scan networks, it scans the networks, and then it prints out all the networks with the name, the signal, and it looks to see if the name of the network contains the word Adafruit, and if it does, and the power is less than 60, because remember it's negative, so the lower the number, the better, because it's a negative. You'll see it's under negative dB, whatever. It'll print star, and it'll say yes, I found it, and then it will blink the LEDs. this basically is that there's LEDs on the module that you can use to like indicate, you know, network connected. So this just manually blinks them in order, and that's just a visual check. So
there's a firmware check.
Yeah.
And then that's something that you had put in as a variable, so that it says like look for that, and
look for the most recent firmware. I mean, honestly, the network scan won't work if you don't have the most recent firmware, because the firmware has to match up. But it just prints it out. It's kind of a nice thing, because if something doesn't pass, you can see the printed out.
Yeah. So it's kind of difficult to put the wrong firmware on it at this point. Like this is what starts to happen. That's kind of nice.
You got to watch out like for wrong firmwares or mismatched firmwares. So this is what happens when you run it.
And this is serial output. It's printing to the screen.
Yeah, this is serial output. And it says, okay, the Wink tester scanning, checks the firmware, and the firmware check passed. It prints out the MAC address. And then it says, okay, I'm scanning for all the networks. And you can see like there's a FiOS network, there's a direct HP Envy, some Linksys from Nextdoor or something, an Apple network, Barnet. And it does find two Adafruit, that's our home network, Adafruit TW and Adafruit, and it says, okay, great, you know, star, 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 I found it. And because it found it, it will then go to the LED blink test. So then if you go to the overhead, I'll show you. The LEDs are blinking in order, so it's kind of a cute little thing. So that's actually the test. So you actually can just run this, like you don't need a computer to look at the output, actually. You can just have it on, and it will, basically if it gets to the blinking LED test, it means it found a network called Adafruit. And for 99% of the time, this is actually a totally fine test. However, for this module, things end up getting a little bit more complicated. So when we buy this module, first off, it doesn't always have the correct firmware. When we first got it, it had firmware, I think 18.3. And that firmware actually wasn't compatible. There was like a buggy. It also didn't have that SSL TLS 1.2 support. And so you might have to update the firmware, which does require a computer. Also, this module supports SSL. And so inside of here is a bit of flash memory that stores SSL certificates. And we're doing some projects with Internet of Things where we want to have certain certificates already burned in for people, so when they buy these modules, they buy the Feather Wink, it already has the most popular certificates installed. We think that's kind of one of those value adds we think is important, especially if we want to do a kit pack that's like, hey, this kit pack is designed for use with Amazon, because Amazon's going to have their certificate. You want to make sure that certificate is installed. Or you want to use this with Adafruit IO. We want to make sure that our certificate for Adafruit is installed, the root certificate. And you just have to make sure that those certificates are installed, so that when it just makes it a little easier for the user, so that they don't have to install the certificate themselves.
Okay, I'm going to press pause on this. I'm going to ask you some more maker business questions.
Ask some questions.
So you're saying sometimes we get the modules and the firmware is different.
It's too old.
Okay.
It's possible, yeah.
Okay.
This happens a lot with things that have systems inside of them.
Yeah. And where's some of the places we get some of these modules from?
These modules come from distributions such as DigiKey,
Yeah.
Mouser,
Okay.
Arrow, Avnet.
Okay. And then the manufacturer of these is?
This is manufactured by Atmel.
Atmel. Okay.
But Atmel, they release stock, and when they release new stock, of course, it's updated.
Yeah.
But there could be a reel that's been sitting on the shelf for 6 months.
Yeah.
And in the meantime, Atmel's like, we came up with new firmware, so that's why you have to do the firmware check.
So here's my question: is why isn't it more visible or easy to find on the markings on the reels or whatever on what version of firmware it is?
I think that it is maybe on the reel packaging, but that package gets torn off.
Yeah.
And it's loaded in. Also, like the
why trust it?
Packaging could be a lie.
Yeah. Why trust it?
You don't know. I'm trying to think of other products where we do firmware update. I mean, obviously, Atmel chips. We
I have other questions with this.
Yeah.
So, because people from Atmel and Arrow and DigiKey and Mouser and lots of other companies, they watch Desk of Lady Ada and they send us emails. Yeah. So what would be a good suggestion? Because I have a suggestion with this, but I'm looking at it from more of a supply chain point of view. You're going to look at it from more of an engineering point of view. When you buy a module, would it be neat to be able to subscribe to the part on one of these sites? So every time there's a firmware update, you just get an email and you can start like, oh, that's good to know, because I don't believe that exists.
Yeah, there is engineering change notifications, ECNs. but it's very unusual to get one for firmware updates. I have gotten them for chips where, like, there was the HDC 1008 humidity temperature sensor, and they actually made a wrong, like, there was it's not a firmware thing, but they changed the design or the packaging or something, and they said hey, if you purchased it before this date code, contact us because the calibration is off. Like, there was a calibration bug or something. Like, it does happen once in a while. And if you purchase from DigiKey, I know for DigiKey for a fact, and I think also Arrow, you get an ECN. If you've ever purchased that product from them, they will send you notifications, but you don't get notifications.
These are for physical parts.
These are usually for like failures.
Yeah.
Or like, oh shit, basically.
Yeah.
Like we screwed up, or we discontinued it, or it's been revised significantly and something's changed that would really significantly change stuff. It doesn't happen for firmware. For firmware, it's kind of your responsibility.
Yeah, because I'm also thinking of other features for the Adafruit learning system where users could subscribe to a learning guide, and if there's any changes, and we can give them specifications on what the threshold for changes. If there was, a typo, don't get an email. But if there was, a significant enough of a change.
Yeah, like let's say change from Raspbian Wheezy to Jessie. Like a lot of our tutorials had to be adapted. Yeah,
and what would be neat is if there was a way for companies like Atmel to put the firmware up on GitHub, and when you get one of these modules, you subscribe to GitHub and or Atmel, and anytime there's a significant firmware update, you get a notification.
Yeah, right now there's actually no way if they come up with a new firmware, there's no way. And for the CC3000, that was another one where there was firmware inside of it. And like there was no way for us to know, and like we didn't get notified. We ended up depending on customers who were like, hey, by the way, there's a new firmware out.
Yeah, and I think
there's a thread in the forum, but I didn't, whatever.
Yeah, and so anyways, part of this is because we know that these large companies are watching Desk of Lady Ada, and they send us feedback, and they like how you're using a lot of these modules. This is how ideas happen. So anyways, I wanted to give people an insight of why things are challenging. Like, we really, really don't know, and you can't trust what's on the chips.
We've come a long way since data books.
Yeah. Okay.
Yeah.
Back to the action.
So this is how, scanning the network and looking for a network called Adafruit is basically how, and this would run standalone. There's been, we could run this without a computer, but we actually wanted to add the ability to update these certificates, and you can't do that standalone. You actually need a computer to run the firmware updating software. The certificate updating software. Also, you might want to update firmware. And then there's another thing. Our network actually changed names. It's no longer at work named Adafruit. And this can happen kind of often. Like, depending on having your tester run in an environment where there's the name of an SSID that's very specific is actually really hard to predict. So one thing you could do is, of course, for one tester, for the CC3000 tester, it was actually looking for a network called Adafruit as well, and I kind of ended up sort of losing the code for the CC3000 tester, and I was about to discontinue it anyway. So what I did is I took an ESP8266 Feather, turned it into an 8 access point mode, and then had it broadcast a network called Adafruit just temporarily while we finished up the last batch of CC3000s. But you don't know what access point they're going to have. You can't depend on, even if you go there and you search for the network and you say, they have a network named this, you can't depend on it. And then you might think, well, I can search for any network. But the problem is you actually want to get that signal strength, right? Because if your antenna is busted, especially if you have an external antenna, you have to have the person testing attach an antenna. If they don't, you might still pick up a little bit of signal, or if the antenna is broken, you might pick up a little bit of signal, or if there's something in the analog front end of the radio, you want to make sure that the signal strength you should be getting is the signal strength you should be getting, right? Does that make sense? Like you actually want to, you could connect to the SSID, but and that is a possibility as well to make sure that. But usually, if you can do signal strength and the name, that for me that proves within 99.9% certainty that the radio is good. So these are balances that you have. If you're doing this at home, you control the access point name. It's always going to be running the front room and your access point is in the living room, you always know the distance. It's not a big deal. But if I was sending this out to a factory, and a lot of people doing electronic manufacturing, they do eventually outsource and they do the testing on site where it's being pick and placed. You want to have something a little more all-in-one. So today was this is one of the things I was working on because I'm trying to get all my Wi-Fi testers off of this search for an access point named Adafruit thing that I've been doing for the last few years, because our access point name has changed twice, and also I'm like, I have to make it more stable, and I want it to be more all-in-one. So I came up with a new sketch, and this sketch is called the access point tester. So what this does is it still, sets up the Wing1500 module, it makes sure it's there, it tests the firmware version, but then it creates a network. Instead of scanning, it creates a new network. And that network is going to be called Wing1500 test. And so instead of the Wi-Fi module looking around for an access point and seeing the strength, what I'm going to use is the Raspberry Pi that does the test and also updates the certificates will look for that access point and make sure that the strength is 100% because it's going to be basically right next to it. And that's how I will, I'm going to do the reverse. Rather than having the module search for access points, the module is the access point and my Pi will search for it. And the reason I'm not turning the Pi into an access point is because I want the Pi to have Wi-Fi connectivity so that if I have to send data to and from it, it's a little, I don't want to set it up as an access point. I want it to be connected to the internet. And this is an easier thing to do on a Raspberry Pi anyways. Although, honestly, you could do it either way, right? You could set up the Pi to be an access point if you wanted, but then you'd have to go in through Ethernet if you wanted to connect to it. And like right now it's on Wi-Fi and I'm SSHing in. So with this program, so let's upload it to the Pi.
Do you want to
Compiling.
go overhead too, or just code?
Oh, no, it's no need to.
Stay on code?
Yeah, it's just uploading. Okay. My serial ports have been a little wonky, but we'll see if this works. Yeah, why are my serial ports so wonky?
Yeah, folks in the chat who do software and more, they agree about two things. First up, yes, it'd be really good to get updates pushed out, like good companies do that, notifying that there's an update. And the other thing is, using a Pi as a standalone tester is a cool idea. We agree.
Okay. So I really screwed up my USB ports on my Windows computer, and I'm fixing them. So I don't know if I'm going to be able to show this on the Windows computer. Don't do what I do to computers. I'm still.
Yeah, you ruin computers.
I really. Well,
you got
this is
8 billion
this
USB
is
ports.
This is a new one. It just really. Well, I remove them, but then.
Yeah.
I'll try one more time. But
yeah, whatever. I mean, you all get the point what we're doing here.
Yeah. I found a COM port, but it's the wrong one. We'll just go to just trust me. We'll go to the Pi and we'll do it here. So now I'm SSHing to my Raspberry Pi. Here, I'll make this a little smaller.
Do you want me to zoom in on this? What do you want?
I can also zoom this out.
Okay, I'll zoom into the.
Okay, so this is I'm SSHing to my Raspberry Pi. Hello. This is my my Pi, and the program that does access point is actually here. I have the binary file here. So with my tester, here's actually the main function of the tester. So actually this does not, this actually doesn't have any arguments. When you come into the main function, I create a GPIO input, button input, and I wait for that button to be pressed. It's number 17, and when it's pressed, I actually keep track of what time it is, and then I run a test, and then depending on whether run test returns true, I print out passed or I print out failed. So this is just the main loop, which is just looking for button presses. I press the button, it runs the test. So that's easy. So let's go to the main run test. I start by looking for serial ports. So I have a little helper in another function, the Python library. that gives me a list of all serial ports. And if I ask, it'll give me the most recently created serial port. Like I keep track of like what serial ports are created and removed. I reset that serial port by connecting it 1200 baud. That's how Arduinos do their auto reset. If you connect the user port at 1200 baud, which is a very unusual baud rate, it's very slow, most people don't use it, it'll actually cause the bootloader to kick in. I then wait for VAD 2341, PID 004B, which is the Arduino VAD PID for the zero bootloader. It basically just does an LS USB until the device shows up. And then I just check to make sure the bootloader port showed up. And then I run BOSAC, which is the bootloader program for the Arduino Zero, to upload my tester code. And the reason I do this is so that if you plug in a fresh Arduino Zero, it'll always update it to the latest code. Also, before this, I would have done some certificate stuff, so the code on the Zero would have been changed anyways. I wait for it to come out of bootloader mode, and then I call that new serial port 0 port, and then I open that port at 115 kilobaud, and then I print every line. Okay, so that was like a lot of stuff. Like what was I actually talking about? So I'll actually show you what that looks like. This is the directory where I'm going to run. Oh, hey, can you?
What? You want?
This has to come. Okay, no, it's fine. I just didn't know if it was zoomed in or out. I will.
Okay, tell me what.
Well, I've got terminals like auto adjust in size. Okay, so I am here, and I will run sudo python wink1500.py, which is my program tester. It says, okay, I'm waiting for button number 17 to be pressed. I actually physically go and press the button on my Pi. Oh boy, this is pretty good. Oh, you know what? I did not plug in the Zero into the Raspberry Pi. Let's try again. Okay, so you press the button. It finds a user port, resets it, finds the boot port. It then should upload code. And then it runs, it programmed it, and then it basically outputs the output of that scanner. Oh, this is still running the old code that scans for networks. So it's looking for the Adafruit TW or Adafruit network. But I'm going to change this from the old code, which was Wink1500, to Wink1500 access point, which is the new program. So quit out of that. I save my Python sketch, run it again. Okay, so this time it's running the tester, the access point test. It finds firmware 1944, and it finds the MAC address, and it says creating network name Wink1500 test, and then it's waiting for OK. So basically it has that network is created, and it's just waiting around. So if I go to my computer, you can see oh, you know what? This is cached. Link, yeah, it was called Feather. Hold on, instead of trusting that computer, let's do iwlist. Was it iwlist? Scan. Sorry, iwlist WLAN 0 scan. Okay, so just like dump me a whole bunch of stuff. Pipe through less, and then search for Wink. So here you can see it, in fact, did find a network called Wink1500 test, and the address is the MAC address, but flipped. Found it on this frequency. There's no encryption key because I didn't set it up. And then quality 100, 100, signal level 100, 100. Okay, so that's good. So I know that the Raspberry Pi has found that access point. So all I want to do now is like kind of automate it a little bit. So if you do an iwlist WLAN 0 scan, unfortunately it gives you that huge amount of data, which is lovely, but I really want it to be a little smaller. So there's another command. which was called WPA CLI scan list. Hold on. Let me remember the name of this. Yeah, this is just like, there's so many options. It was something, not list networks, not get networks, scan results. Okay, so quick. So you do WPA CLI scan. So does a scan, and it says, okay, did a scan. And then you say scan results. And it will give you a much nicer list of all of the scanned SSIDs, and you see the ATWINC1500 test down here, and it gives you that MAC address, and it gives you the signal level, and it gives you the SSID. So this is kind of handy. I can now, within Python, use this output to determine that my Wi-Fi module is working. So let's go back to editing this code, and I'm going to comment out this section which waits for that button press. And instead, after run test is done, I'm going to exit, just so I don't have to keep going over there and pressing the button. Honestly, if I really want to, I would make this all smaller and simpler anyways. So here at opening 0 port, and this is when I open that port and I open the 0 port and I print out every line. So, okay, so I've tried line, I print out the line. So this is where I actually want to check for stuff. So the output, first off, I want to get that MAC address. So if MAC in line, and then I'm going to print colored teal found MAC address. So that's good. I need the MAC address because I want to search for that. Don't search for the name of the SSID, search for the MAC address. It's a little wiser, especially if you're having 2 or 3 testers at a time. You don't want them to cross-find. This is an issue that comes up when you're testing Bluetooth modules, Wi-Fi. You don't know that the module you're testing is the one that's connected because it's wireless. Like, if we were testing 2 of these, they could cross-talk. So if you search for the MAC address, not the name, you're going to find the absolute correct one because you know the MAC address through the serial port. It's the same one that's mechanically connected to the Pi. So there's an issue with wireless that can come up. Okay, so we found the MAC address. That's good. And then once it prints out the MAC address, you want to look for it saying creating network. Or actually, you want to search for waiting for OK. So if waiting for OK inline, then I actually want to run that those 2 functions. And the functions were, and I'm going to use OS system for this to start the scan and just to make sure it finishes. It was WPA CLI scan. And then I will look for the output. So there's only one thing that's a little weird here. The output of WPA CLI scan results. So down here you see the MAC address. The problem is the MAC address is flipped. So see, it's like here, the MAC address is 6D, 96, F1, 5, F0, F8. But the MAC address over here is F8, F0, 05, F1, 96, 6D. So it's like each octet is every byte is flipped around. So what we want to do is update. I mean, like, we can do this in Python, but you know what? It's just easier to do it here. When we print out the MAC address, we print it out in the opposite order. So instead of going 5, 4, 3, 2, 1, I don't know why it's backwards, but we go forwards. 2, 3, 4, 5. And then another thing to watch out for, and like, I didn't get bit by this, luckily, because this MAC address is has this issue, so it wouldn't have happened in the future. This byte here is printed out 05 here, but printed out 5 here, because there isn't that leading 0. So you need that leading 0 to make sure that you get the right matchup. So over here, you know, I could do printf and stuff, but you know what? I'm just going to make it simple. If max 0 is smaller than OX10, then serial print, just print a leading 0. I mean, it's super simple. It's just like one line. So just copy and paste, change this to 3. Yeah, it's just a matter of just like, you know, just you have to manipulate data to match whatever the Linux thing expects. Okay, and then 5. So we'll compile this, and then to get it onto that Pi, remember like the Pi connects to the Pi 0, the Pi connects to the Arduino 0 and updates the code. So all I have to do is grab the code, which is in this directory, and that's the new binary file. And in GitHub, I actually have all the files for this stored on GitHub. I just drag and drop it onto here, commit it, and then over here I do a git pull. Oops, nope, I typed it right. So it updated the binary file for me. So let's try running it again. Oh, whoops. Teal's not a valid color. I keep forgetting that. Teal, let's do magenta. Scripted languages. Okay, so here now the MAC address that we have printed out, F8, F0, F8, F0, 05, F1, 966D is in the same order and has that leading byte as the WPA_CLI scan results. So that's really nice. So the only thing I have to do now is grab this string from the output and then convert it to lowercase, because for like whatever weird reason this is lowercased. Okay, so more Python. I'm sure people who like really know Python are like horrified by my Python, but like whatever, I get it working eventually. Okay, so what I'm going to do here, I have to remember how to do this. It's I'm going to cheat because I actually worked on this earlier. I'm going to look at it was, okay. I never remember how to do regular expressions in Python. Why can't it be like Perl? I don't know. Research, and then I'm going to put my regular expression in there. Line. Okay. So I found the MAC address. So now I want to search and grab out that line. So do regular expression. This R just means treat this as a raw string. And the MAC address looks like 0 through 9, A through F. And then also colon, star, actually plus. So some string of 0, 9 AFs and colons, that's what it's looking for in the MAC address. Right? It's gonna pick up this string here, and then it'll print out the MAC address here. Actually, let's Okay, so the MAC address is this. Print out, print MAC address, MAC adder. Okay, and then, you know, honestly, when it finds the, well, that's fine. Okay, so let's run the tester again. See if it picks up that regular expression. Okay, it did, great. So it found the MAC address, and that's the string it found. So now I have to actually change this to the creating network in line. I will run WPA cli scan. So that will actually run the scan, and then I have to get the results. So to get the results out, I actually have to use, I can't use OS system. Instead, what I'm going to do is run a sub-process. And this is just like a different OS system. When you do that, it actually just runs the command like it was in the shell. What I want to do is I want to grab that output and then look through that output to make sure that it has the MAC address I want. So I'm going to use sub-process. So again, I'm going to look at this other tester to remember the sub-process. Okay, this is what I want. Okay, and I'll clean that up. So start by, what is the command you want to run? I want to run WPA cli, comma, and then scan results. So you put that in as an array or a list. You pipe the output to std out, and then, or sorry, you take the output and you pipe it out back into this std out read, so you can actually read the output. You just check the return code. You can read the output. If the return code is not equal to 0, it means it failed. And then at the end here, you have ret. Ret is the stuff you got. You can print out ret. So let's try that. This should run the scan and then print the output. Okay, so great. So we found that MAC address, and then afterwards, it ran the output of WPA cli scanned using WLAN 0, and then actually got me the output. And yes, you can see that at the very bottom here is this item. So what I want to do now is I'm actually going to do the same thing again. I'm going to do a regular expression on the output of ret, and I'm going to look for this, and then I'm going to grab this number. This is that signal level. Remember, I want to check the signal level and make sure that it's higher than 80 or whatever. And if it's higher than 80, then I know, like, okay, you know, the network is good. So I printed it out, and I'll comment this out later, but now I'm going to do another regular expression search. So search for regular expression. And then I want to search for the MAC address. So I start with that, but I want it to be lowercase. So MAC adder lower. Pretty sure that's how you do it. Plus, and then there's a bunch of spaces. So that's back S plus to say any white space, because I don't know if it's tabs or spaces or whatever, just get all white space. Then there's a bunch of numbers, which I don't really care about, but I'll grab those anyways, just say, okay, skip past those. More white space, and then this is that thing I want to grab. So you put parentheses around it, 0 through 9 plus, and that will get me the signal level. Okay, so that's, and then don't forget to put a R in front for raw, because otherwise the backslashes have to be backslash, and like it's a pain in the ass. So, and I don't know, I think it maybe also wants to be single. I always notice whenever I do regular expressions, I have a single quote, so maybe that matters. So that's our regular expression. Let's see if it's good. As JWZ said, I've just created another problem. So it does the search, and then I'm going to print both the group 0, which means the entire matched item, which is search obj group 0, and this always means like the entire thing, not the parenthesized item, which is group 1. And then on the next line, print out group 1. So make sure I grab the whole thing and then print out just the signal strength. So let's run this. Oh. Scripted languages. They're great, except when, they don't really check anything for you. Forgot I have to put in that search term into the argument. Okay, so this time it ran the scan, it gave me the output, and then it did in fact find, in here, remember it's not always the last line, it did find that WINC1500 test. This is that regular expression search group, and then this is the output of the signal level. Actually, maybe I'll make this, colored so you can see. It's a little tough to see with the white text. Okay, so this is the output of that scan, which I printed. This is that matched regular expression, which is awesome. And then this is the number that I'm actually looking for. So if this, I have to make sure that this, this successfully works. But if this worked, then this number will tell me that as long as this number is larger than like whatever 80. So I'm going to say sig strength equals and actually put this in I'll put this in a try block as well. So I don't need to look at this ret. I will comment this out. It's good to have the other one. And then also, honestly, this WPI scan, it can go into dev null. I don't need to look at the output. If signal strength is lower than 80, return false, else return true. That's kind of it. I mean, that's all you got to do. Like you're grepping for this line, you find it. This is going to be fine. Where this would really fail. I'll put the whole thing in a, yeah, you know what? I'll put the whole thing in a try block. Later, I'll take this try block and change the except so it covers the whole thing in a little bit. But now it actually does exit out. So let's run our new fancy program, found the MAC address, found the access point, said it passed. Great, we were able to test this all in about 5.5 seconds. So let's look at what it looks like if it failed. Let's just say I wanted 110%, which is not possible, but let's make it impossible for it to pass. So you see what it looks like when it fails. Oh, see, something went wrong. If it's smaller than, why did it return false? That's interesting. Did I save this? Do I have to cast this as an int? Oh, you know what? Why is there? No, I'm suspicious. I'll try this again. That should have failed. Should have been cast as an int though. Okay, there you go. So you have to see, loosely type languages. So I had to make sure that was, you want to black box test your stuff. So if you have a test that's supposed to fail, make sure it actually fails. So in this case, the signal strength is not good enough. It says it's failed. So I'm going to go back and change this to 80 again. Now that I know that that's good. Actually, I'll change this to be int. So do the casting early. Save this, and then I'm going to re-add the button. So now the button is required, and when it's done, it will loop. It won't exit. And then I'm going to git commit it.
Is the frequency important at all?
It's not. Oh, you know what? I want to, hold on. Sudo, I want to add a couple of things. 1 second. Sudo add, git add 0 helper, and then the wink15 py, and then I want to save my work before I do any more. Okay, so root, it is working and using access point mode. Okay, sorry, what was the question?
Is the frequency important at all?
It isn't important for me because I don't know that I can control it. I believe that the firmware inside the module just picks whatever channel. I could dig into it, but I don't really care what that is. All I care is just testing the radio part. Like, I don't have to test whether like SSL works, because honestly, either the chip works or it doesn't. If it is able to get radio and it's able to transmit packets, that's functional enough for me. So now this is updated on GitHub, which is kind of handy. So I don't have to worry about losing my work because it's now saved on GitHub.
Are the permissions protected so someone can't just change the files accidentally?
No, it's because I was doing stuff as root, and when I first cloned it, I was root. Because actually, so this tester is in my home Pi directory, but that's not actually where it should live. Where I put the tester is in boot testing. And that's fine, it just has ownership issues when it goes into boot. So the boot directory is the directory that appears on a Raspberry Pi when you plug in the SD card. So let's say I update the firmware again. Instead of having to SSH into the Pi and do a git pull, by having all the files stored on boot, when I'll show you all unmounted, I'll show you a little bit later, the files are now accessible by anybody who just plugs it into a computer, and so you can do a git pull, or you can copy over files just by plugging into any Windows or Mac machine. So now I have all these directories, because I actually have one image with all of the testers. I have all the PIDs set up here. And now that the tester works, let's, I have, the way I have this Pi set up is instead of opening up a shell, it actually runs this program called tester.sh. And what tester.sh does is you can uncomment the lines you want to test whatever PID this is going to test. So I have one SD card image, and it has all of the code for all the testers on it, and all you have to do is edit this one file to configure it to which one of whatever you want. That way I don't have like 10 SD card images, which is a total pain to keep track of. I have one master SD card image. You burn that to an SD card, you uncomment this line, and tell it which program you want to run. You have to remember to do everything as sudo. So once more with feeling. Go into PID 2999 and run wink1500. So let's shut down, and I'll show this to you. Okay, it's going to, yeah, once you go to, you can go to quad cam if you want. Okay, so waiting for this Pi. Okay, so this Pi now says it's going for a shutdown, and it is, the activity light's off, so I can unplug this. And then if I take this SD card and I put it in my SD card reader, this is a new reader, so I gotta figure out, how do I, there you go. Okay, so on my computer, when, oh, can you go to just computer cam? It's supposed to computer cam today. So when I plug this SD card into my computer, it says, okay, you know, you've got this directory boot. And in that directory, you can see here are all my files. I can do a git. Oh, I can do a git git pull. From here, I don't have to log into the Pi itself if I have to update the code for it. And I can also edit that test.sh file. So if I want to change what this tester tests, I just commented these lines, uncomment the other, save it, and then when it boots up, it'll automatically run whatever test I want. Okay, so that being done, let's eject it. So that's my master SD. And then let's go to overhead cam. Okay, so now I'm ready to pretty much try out this PyTester. I don't know if it's going to work, but we'll find out. So that's the SD card that is configured now to be a PAD2999 tester. Plug it in, power it up. And it comes, you know, with PyTFT built in. It boots up PyTFT. Okay, and then can you zoom into the display that super zoom? Hold on. Okay, so it boots the Pi, and that's the, you know, hey, I'm a Pi, I boot it up. And then you can see here it says PAD2999 waiting for button 17. So it's basically, it launched right into the tester. You don't have to log in or anything. So this is perfect for people who don't know command line stuff. They don't have to log in as Pi. Basically, you just configure the Pi to log in automatically, and then just in your .bash profile have it run test.sh. And then this button 17 is the button you press. And then it's running that same software that you saw on the SSH, or SSL client. Uh-oh. It didn't work. See, that's why you have to debug your tester. I think I have to put a bit of a pause. Let me try running this manually. And I didn't put that try block. You see what happens when I didn't put that try block in? I should have put that try block in. And this is where I actually start like doing the tweaking. So like sometimes I have to put in delays or put try blocks in. Okay, second time is a charm. It ran, found that MAC address, as you know, in the purple text, creating network, found that, and then it did that iwlist scan. Could be like it, you know, when I ran that just a second ago, like I needed to put a delay in and I didn't, or maybe honestly the Wi-Fi module might not have come up. Sometimes they take a couple seconds to bring up the WLAN object. But now that it's passed, you can check the LEDs, make sure that the LEDs are blinking, and that would tell you that it's good to go. You can then, you know, cycle out the module, grab another one, insert the module, and then press the button again. And it passed. So as long as they're looking for that green pass text, that makes it very, very easy for people. And, you know, as I do more, I start commenting out all the debug. Like I would probably comment, you know, this out or make this not red so it's not confusing, or make it purple. And that way people only have to look for the green text. It's just a user interface type thing. And then when we're totally done, we make one nice final Raspberry Pi enclosed, you know, it was on one single plate, so this isn't like kind of dangling here. We use a shorter USB cable, so there isn't like this long USB cable. Maybe I use a Wi-Fi module that doesn't have a huge antenna. Basically make it as compact as possible. Basically, then what I do is when we're at work, I'll have people who do the testing, I'll say, hey, can you test 50 of these and tell me what failures occurred, or like what did it ever crash? Because again, it's a language where you have to put try box, but you just never know. Like you could have parsed something wrong, or what if it isn't an integer? There are all sorts of things that could happen. Depending on what you're testing, you'll run across all sorts of weird effects. And so having someone test 50 and just letting you know, hey, it crashed if I ran it too quickly, or if you double click by accident, like it all goes to hell. You can go in and tweak the tester code to account for all of these possibilities. And this is a really nice Instagram showing all of the testers that we worked on last week. So you can see that clamp, the same clamp basically that we had to hold the device under test. And then it's next to a Raspberry Pi. Those are Raspberry Pis with Pi TFTs, and they're in nice little cases. So I'll show you one of the cases. So it looks like this, where we have our nice faceplate that we sell in the store. It's like, hey, like we carry all this stuff. So it's like a Pi in a nice case, and then it has the cover on it. So it's all very organized and clean. It makes it very, very easy for people. Because my job is basically to make it as easy as possible for the people who work at Adafruit to be able to run the test procedure. So this isn't done. I actually have to, I kind of gutted a bunch of the code that does the certificate updates, so that wasn't actually done in this test. So what I have to go back now is basically take that code that I deleted out and put it back in. When it first connects to, when you first press the button, actually instead of running that access point scan, it updates the Arduino 0 with the firmware updater firmware, then runs a tool called certificate uploader, uploads those certificates, then it can upload the self-test. So there's a couple extra steps involved. But what's nice about using an Arduino and a Raspberry Pi as a base is I get all the power of Linux, like access point scanning. It's all built in, Python and shell redirection and the Pi TFT. That's super, super easy. I'm just using Python and all the built-in functionality. And then I have the bitbank capability of the Arduino 0. I can have it run any code I want that will actually do the SPI control for controlling this module. Yeah, so that's it. This is one of the more complicated testers, but you can see how designing the tester actually requires a lot of different skill sets. So you want to know Python, shell scripting, Linux, Arduino, like you'll use all sorts of weird tools, like command line tools. You have to think creatively, how am I going to test this radio? Like, what if I don't have an access point? What if I'm sending this to a factory and I basically have to have it all contained? Thinking about the tester a lot will save you so much effort and confusion later, because if you're getting something manufactured, if you can't have them tested on site, you're going to have a lot of issues where customers get it and something's wrong. But you also have to make sure that the tester design for people who have no idea what your product is, it basically has to either light up an LED green or red. I mean, that's how simple it has to be. Any text has to be very straightforward about what is going on, because the people who are going to be reading it are not the engineers who designed the product, unless you're willing to go to Shenzhen and like live there for a month, which is suggested, but a lot of people don't do.
Okay, I can answer the next question here.
Yeah.
It says, is there a journal to your testing system? For example, 90% pass, 5% failed, signal strength 5%, failed, no power, etc. Yeah, it's in our work order system.
We do know work order system. I will tell you that if I was doing a more complicated product, like a laptop, what you do, or if you're really outsourcing it, or like there's this, like, because we do it in-house. So if there's an issue, Sully will come over and be like, hey, Lamar, like I was testing these and I got like 4 in a row that had this, or like I got a whole panel that had this error. And I'd be like, whoa, that's really weird, like that shouldn't be happening. So I had a little bit more flexibility than a lot of people. But if I was designing, say, a laptop or a tablet, or really anything more complicated than the breakouts and feathers that we do, that are honestly, there's not a lot of complexity to them. I want good yield, but there's not, like I can test them within 30 seconds. if you're doing something more complicated, that you would, a Raspberry Pi is actually really good, because what you want to do is have that Raspberry Pi send you emails or data every day saying, here's the serial numbers that I tested today, here's the results. Like, that's very, very valuable. So for that, of course, you do have to go there, or you have to get them to give you the SSID name and password. And, you know, especially if it's in Shenzhen, you have to make sure that you can get out the network to send an email. But you'd have your Raspberry Pi actually report back to you with how many it tested, the serial numbers, MAC addresses, the results, any failures it would tell you, because it has happened that we've heard of factories that they'll lie about the yield results, or they'll say something passed that didn't quite pass, or they'll manipulate the tester to make things pass when they shouldn't. And so, you know, we heard of someone saying, and this is really egregious, it's unusual. It was a motherboard, and the people who were testing it, what they would do is they would say, oh, we ran the tester 50 times, but what they did is they ran the tester 50 times on one board, and then they snuck 49 past. They didn't actually do full test on them. Yeah. So, like, that's really scary, right? You know, like, what if the people who are supposed to be doing tests don't actually test? It's a possibility. So the next time this person was going to the factory, he basically set it up so it would email him the report at the end of the day. What was the serial number? And it had checked to make sure that it was a unique serial number, and check the MAC addresses, like things that were permanently burned into the chips. Like if the Wi-Fi chip or the Ethernet chip, it would use that to help identify that it was doing a unique one. Like, for example, you know, if you're using FTDI chips, they come burned with a serial number. You would use that as a unique identifier. Or again, MAC addresses are excellent, because if you're buying Wi-Fi, Bluetooth, or whatever, it comes with a unique identifier already burned in. Sometimes chips have unique identifiers as well. So check, you know, there's little things that you can use to make sure that you can verify that you really are testing what your factory is supposed to be testing.
Okay, next up is, why do you use the long pogo pins? Any preferences?
I just like these pogo pins. They work pretty well. I've had them go through tens of thousands of cycles without any issue. They're cheap. I design my testers to be disposable. I know that there are, sometimes you have to, you know, you design testers with holders and like, so you can swap out the pogo pins. But, you know, really, honestly, the way we design the testers is we make them so they're very cheap, very easy. And we once you have this system set up where it's laser cut, and you have the Raspberry Pi and the Pi TFT and the clamp, these are all parts that are either 3D printed, laser cut, or that we stock in the Adafruit shop. So when I go in on Monday and I say, hey folks, like I designed the PAD2999 tester, it's done, they'll run into action and they'll immediately duplicate what I did, clone the SD card, get the same Raspberry Pi, the same clamp, you know, the same pogo pins, and set up so that we have 3. And that way we'll have 3 testers so that we can test multiple at a time. We can have multiple people testing at a time. If one breaks, you can always grab another one. Really important, don't have a single tester.
Yeah, I can answer this last question. Any updates on Circuit Playground? Yes, the circuit boards are coming in, and I'm pleased to announce we'll be having an entire series of videos all about Circuit Playground, how we made it, what we're doing, features, what it was like getting it ready for manufacturing. We're going to be doing something cool with DigiKey. I mean, I'll just say it. Like we're going to show our work more so than ever with a specific product.
Yeah.
So if you like this tester video and like how we do manufacturing, you're really going to like the backstory.
I can show it. It's not out yet. Don't ask. Do you want to do that? Or is it too risky?
No, there's some cool people in the chat. Let's.
Are they cool? Have they been nice?
Yes.
Okay. So this is the prototype for the Circuit Playground tester PCB. So it's got these side clamps. I mean, this tester is not so hot, but it's cut on the other mill. It's got pogo pins all around. It's got these 2 position holes. These are the 4 pogo pins that will be used for ISP programming. And these are the little clampy bits. So when you go to test, they'll clamp down. I mean, it can't do it with this because it's got these wires on the back, but it'll grip it in place. And so I'll be able to use this as the jig for programming it, maybe. Still kind of working this out, though. This isn't completed. yet. But this was a first draft. This is kind of nice. So instead of a toggle clamp, it does little side clamps. Hi, you're so cute. Hi, little tester. So we'll see.
Okay. And with that is your desk of late data. Thank you, everyone. Thank you all the folks that work with us, and thank you for the community of nice people in the chat, and really good questions, and a lot of people who do engineering and software had a lot of good things to say.
Yay! Yeah, this is. Yeah. I mean, this is.
This is so neat because someone noticed in the chat, and I briefly talked about it. No one shows this part of manufacturing.
I know. I think people must find it so boring because it's. It's really, it's kind of not.
It's not boring.
It's not like, hey, I'm like doing, I'm internetifying my toilet. It's like this is just like the kind of the sausage making behind the scenes. What I actually do all day is a lot of tester design. That's kind of my gig. Like I love designing new hardware, but I have to do a lot of maintenance to make it so we can manufacture. Like I live and die by the yield that we get out of the fab department. If like we've actually been having 100% yield lately, which is amazing. Like we'll make 2,000 of something, and 2,000 of them will pass test. That depends a lot about, of course, your pick and place and your oven, but also depends on, is your tester good? Because if your tester is too strict, it won't pass things it should pass, and that's not good because you have failure. You basically have wasted product, and you can't make it too unstrict because you don't want to send things to customers that are broken. So it's this balance, right? Again, I could have had this module where it has to connect to an SSID and it like transmits a file, but that would take even longer. And then there might be, there's another possibility. Actually, this has happened. I did have a test once for the ESP where it would connect to the Adafruit SSID and ping Adafruit.com. And guess what happened one time? Yeah, it happens. Sometimes your site's down.
I remember Samsung, all of their TVs were internet connected TVs, and the Samsung building caught on fire and their data center went down, so you couldn't watch TV, and people are like, oh my gosh, this happens.
Yeah, and immediately it was just this one time where either the network was down or Adafruit.com was down.
Yeah.
And I was like,
couldn't test.
And actually, so we had and the person who was testing, they don't know. They're just like, oh, it's not failing, it's failing. Oh, we've got a bad panel. And after they got bad, luckily after 20, they came to me and said, hey, that's really weird. These are coming down. And I said, oh my God, I know exactly what's going on because the network is down right now. We were doing a switchover or something. And then I realized I really can't, these are things that happen. You can't depend on, when you design testers, you have to have this crystal glass. It has to be this perfect universe that doesn't change. Yeah. Because your El Capitan updates, now your ST-Link doesn't work. Your Wi-Fi changes password or name, now your tester doesn't work. I mean, all these things that occur can make your tester not work, and that's why I'm trying to make them all these little mini universes, right? So this is kind of this is fun. This is a little bit of a puzzle that you get to. This is the fun part. This is a puzzle, how to test what you have to test.
I think also there's an art of engineering. I think you've done a really good job showing that. But I also think there's an art of the process. And the art of the process is making testers is cool. It's a contraption. There's code. You have to be an engineer, and then you have to be an engineer that can imagine someone who isn't an engineer doing the testing. It's really neat. It's it hits all.
Yeah,
all parts.
A lot of our testers used to be on a Mac or Windows computer with the Python you'd run in the command line, and actually we've had people who are never used a command line. They have never run Doom in DOS mode. It's they're younger and they just have no experience with command lines. And I'm like, oh, right. Not everybody knows it. And I'm like, okay, I got to redesign this stuff so that you press a button.
Yeah, I'll say straight up, as someone who's interviewed at least 100 people in the last couple years at Adafruit, I've been in every interview, the generation of folks that are out there, this millennial group or whatever person who walks in the door, there's a good chance the way they use computers is very appliance-like. It's not the way that we use them, which is we used to build them. And we kind of knew everything about it, and we would install Linux on different stuff. they're getting completely finished things that have never been opened up, like an iPad or an iPhone might be one of the only ways that they use technology.
Yeah,
it's very
like
different.
I use keyed connectors, because it's like you and I know, like because we've put together, like serial ports on ISA cards, so we know. Oh, you match the red wire to the white dot. The pin 1 is red wire. Most people do not know that. So if you don't use a keyed connector and the cable comes loose, or they have to replace the cable, because by the way, if you have a cable, like let's say you're using an ISP cable from a USB-T and you're an AVR, you're not using pogo pins, you're actually plugging the cable in. Especially SWD cables, because those cables are very fine and they do break after a couple hundred revisions. You have to make sure that people can replace the cable. And you have to make sure when they replace the cable, they don't put it in backwards, because it's very easy, right? You flip it and you're not paying attention. So you have to make sure that your connectors are keyed, so that if they plug it in, there's no risk of them putting it in backwards. And you can't just tell them you can try to tell them like, oh, match up the red wire, but it's actually not. It's better just to make it mechanically very simple, and it's nothing against them. I mean, they actually, it's just something you have to think about when I was like first doing stuff. I was like, oh yeah, okay, open up a terminal and run AVR dude with this, and like that's over. The days of me being able to just like tell the person who's sitting next to me, who's also the web developer, hey, let's program some chips. Okay, just run AVR dude is over. And now it has to be a single button, and it has to just green light or red light. It has to be super easy.
Yeah, and then we're going to get out of here now, but the last piece that I would say is when the company you buy electronics from cares this much about our
Okay,
testers.
so I want you to look at this. They color matched it.
Yeah.
Okay, this is I think Dano and Sully. So each tester, these are 6 different products, and each product is color coded.
Yeah.
It's very, very smart of them, because again, the testers look very similar.
Yeah.
And so each product, there's the white tester, which goes with one product, the yellow tester, the red tester, the glam mirror there's a mirrored acrylic one, blue and black. And so they have a different color. And then, this tester that I'm designing now, they'll probably make green or something. So each one has a color. And so that's another signal to someone to make sure that they grab the right tester. Not just the PID number, but make sure that the tester color is correct. Because when they look at the instructions for how to run it, if the color is wrong, that's a hint that maybe they grabbed the wrong one. Again, the board wouldn't fit, but sometimes if it's a feather, maybe it would, right? Because if you have boards that are very similar and they would fit to the same pogo bed, you have to check. You have to think about this. So these are like super beautiful, and they match the case of the Pi is also the same color, because we have all the different. We have like 9 different color Pi cases. So this is like super fancy. This is like fashion.
When buying electronics, ask to see the tester, because it matters.
Yeah.
Okay.
And this is the final evolution. I mean, we're going to keep going with the evolution of testers, but this is, if you compare it to the testers we used to have, this is like amazing.
Okay. Thanks so much, folks. That was your Desktop Lady.
Okay. It's tester update. So I've got a couple more testers, but then we're going to get back to engineering. I only have to, I have a list, and this is, I did the FONA 324. I'm doing this WINC1500. Tomorrow I'm going to do the ESP8266 Feather. I'm probably not going to broadcast it. And then we'll get back to engineering next week. I had a little bit of a tester palooza. But everybody in Fab is so happy. They gave me a hug report.
All right, that's your Desktop Lady. Thank you,
All
everyone.
right, thanks everybody. Good night. I'm going to turn into a pumpkin.